Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths Practice Questions on Arithmetic Progressions. So if you need any extra help on Arithmetic Progressions, if you go to Corbettmaths and go to the Videos and Worksheets section and scroll down to video number 374, there's a dedicated video tutorial there on Arithmetic Progressions. Alternatively, you can scan this QR code and it'll bring you straight to the video, or I'll put a link in the top right hand corner, and if you click that link, that'll bring you straight to that video as well. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, so here's question number one. Question number one says, here are the first four terms of a sequence. And we've got 17, 21, 25 and 29. And part A says, work out the next term in the sequence. Now if we have a look at the sequence, we're adding 4. To get from 17 to 21, we add 4. To get from 21 to 25, again we add 4. And to get from 25 to 29, we add another 4. So we've been asked to work out the next term in the sequence, so we just need to add another 4. And 29 plus 4 is equal to 33. So the next term in the sequence is 33. And part B says, explain how we worked out the answer to part A. Well, let's just explain that. And that's it. I've just explained that the common difference is 4, and to find the next term we just add 4, so 29 plus 4 is 33. Okay, let's look at our next question, question number 2. So question number 2 says the first two terms of an arithmetic progression are 6 and 12, and we've been asked to work out the next term. So we've got 6 and 12. Now remember, with an arithmetic progression, that each time we're going to be going up in the same step or down in the same step, so we're going to be going up in the same number each time, the common difference. And as you can see, to get from 6 to 12 we add 6, so to get the next term in the sequence we add another 6, and 12 plus 6 is equal to 18, so the next term in the sequence is 18. Okay, question number 3. So question number 3 says an arithmetic progression begins -2, 8, and then we've been asked to work out the next three terms. So we've got -2, then 8. Now remember, it's an arithmetic progression, so it's going to be getting bigger by the same number each time, so we're going to be adding 10 here, so add 10, then add another 10, so add 10 will be equal to 18, so that's the next term. We need to find the next three terms, so then that'll be adding another 10, so add another 10 is equal to 28, and adding another 10 will be equal to 38. So the next three terms were 18, 28 and 38, and that's it. Okay, let's look at our next question, question number 4. Okay, so question number 4 says, which of the following is an arithmetic progression? Circle the correct answer. So we're going to be looking for the numbers that are going to be going up or down by the same amount each time. So 3, 6, 12 and 24. Well, actually this time we're multiplying by 2, multiply by 2, multiply by 2. It's not getting bigger by the same amount each time. So if we check, it's add 3, add 6, add 12. So it's not going to be that one. 3, 6, 9, 15. So it goes bigger by 3, gets bigger by 3. It seems promising, then gets bigger by 6. So it's not that one. And this one's actually a Fibonacci style sequence, because 3 plus 6 is equal to 9, and 6 plus 9 is equal to 15, and so on. Okay, the next one, 3, 4, 6, 9. Well, it gets bigger by 1, then gets bigger by 2, and then gets bigger by 3. So that's not an arithmetic progression. And then finally, 3, 5, 7, and 9. Hopefully it's going to be this one. It gets bigger by 2, so add 2, then add another 2, and then add another 2. So it's that one. And we've been asked to circle the correct answer, so let's just circle it. That's the correct answer, 3, 5, 7, and 9. Okay, let's look at our next question, question number 5. So question number 5 again, we've been asked which of the following is an arithmetic progression, and we've been asked to circle the correct answer. So 32, 16, 8 and 4. That's a geometric progression. Each time we're multiplying by half, or we're dividing by 2 each time, so it's not going to be that one. 32, 30, 26, 20. We'll get smaller by 2, it gets smaller by 4 and smaller by 6, so not that one. This one, 32, 25, 18, 11. So to get from 32 to 25, it goes down by 7, and then goes down by another 7, and then goes down by another 7. So that's an arithmetic progression, because it's getting smaller by 7 every time. It's getting smaller by 7 each time. So that's an arithmetic progression. And finally, our last one, let's just check and make sure this one's not an arithmetic progression. 32, 8, so it gets smaller by 24, then it gets smaller by 6. No, it's not that one. And that's it. Actually, this one is divided by 4, divide by 4, divide by 4. So it's not that one. So the arithmetic progression is 32, 25, 18, 11. This one here. Okay, let's look at our next question, question number 6. So question number 6 says, here are the first 5 terms of an arithmetic sequence, and they are 9, 13, 17, 21 and 25. So it's the first 5 terms in an arithmetic sequence. And as you can see, it's getting bigger by 4, getting bigger by 4, adding 4, adding 4. The common difference is 4. And then the question says, is 68 a term in the sequence? So if we keep on adding 4, will we get to 68? And we've been asked to explain our answer. We're adding 4 each time, and if you have a look at the numbers in the sequence, 9, 13, 17, 21, 25, they're all odd. So if we keep adding 4s, it's just going to be odd every single time. So 68 will not be in the sequence, because 68 is even, and all these numbers are odd. So let's explain that. And that's it. I've just explained that no, all the terms in the arithmetic sequence will be odd, but 68 is even. Okay, let's look at our next question, question number 7. So question number 7 says, Edwin has the following number cards. So Edwin's got these number cards, 6, 8, 12, 13, 17, 20 and 21. And Edwin chooses 3 of the number cards to make an arithmetic progression. And we've been asked to write down 3 possible number cards that he could choose. So we're going to be looking for 3 numbers that whenever we put them into these spaces here, that they will make an arithmetic progression. So that means they're going to be getting bigger or smaller by the same amount each time. So I'm thinking perhaps if we start with 6, and then 13, that gets bigger by 7. And then if we add another 7, that'd be 20. So 6, 13 and 20 gets bigger by 7 and then gets bigger by 7. You could have those the other way around with 20, 13 and 6 getting smaller by 7, get smaller by 7 and so on. So that's one possible option, 6, 13 and 20, add 7 and add 7. Now I can actually see there may be other answers here. We could have 13, 17 and 21. Add 4, so we could have 13, 17 and 21 and so on. So as long as you choose 3 of these number cards that they've got the same difference each time, then they will make an arithmetic progression. So 13, 17, 21, add 4, or 16, 13, 20, add 7, so they all work. Okay, let's look at our next question, question number 8. So question number 8 says, here are the first 4 terms of an arithmetic sequence, 2, 7, 12, 17. And we've been asked to find an expression in terms of n for the nth term of the sequence. So we need to find the nth term of the sequence. And if you need to go back to Corbettmaths and revise the video on nth term, feel free to do that. And actually I'll put another link in the corner here. So if you click the link in the top right hand corner, I'll bring you to the Corbettmaths video to explain the nth term. But let's have a look at this question now. Okay, so we've got the numbers 2, 7, 12 and 17. So let's have a look. They're getting bigger by 5 each time. Add 5, and add 5. So in terms of a set of numbers that get bigger by 5 each time, I'm thinking of the multiples of 5. So 5, 10, 15 and 20. And let's let that be 5n. 5 times 1, 5 times 2, 5 times 3 and 5 times 4. So because the sequence was getting bigger by 5 each time, I've written down the multiples of 5. 5, 10, 15, 20. Now this is 5n. We want to find out what it would be for the sequence. We want to find the nth term for the sequence. So to get from 5 to 2, we take away 3. To get from 10 to 7, we take away 3. To get from 15 to 12, we take away 3. To get from 20 to 17, we take away 3. So that means the nth term of the sequence will be 5n, take away 3. The multiples of 5, but 3 less. So 2, 7, 12 and 17. That'll be the nth term of that sequence. And just remember, if you go back to the beginning of this question, there was that link in the top corner, and if you click that, that'll bring you straight to the Corbettmaths video on the nth term. Okay, question number 9. So question number 9, it says here are the first 4 terms of an arithmetic sequence, negative 14, negative 3, 8 and 19. And we've been asked to find the nth term for that sequence. So let's write down the sequence, negative 14, negative 3, 8 and 19. It gets bigger by 11, 11 and 11. So let's write down the multiples of 11. 11, 22, 33, 44. And that would be 11n. 11 times 1, 11 times 2, 11 times 3 and 11 times 4. Now, if we have a look at our sequence isn't the 11 times tables. It's not 11, 22, 33, 44. It's actually negative 14, negative 3, 8, and 19. So we need to take away a certain number to get our sequence. So it's going to be 11n minus, and to get from 11 to negative 14 we'll be taking away 25. To get from 22 to negative 3, we'll be taking away 25. To get from 33 to 8, we'll be taking away 25, and so on. So it's going to be 11n minus 25, and that's it. That's the nth term of that sequence. Okay, let's have a look at our next question, question number 10. So question number 10, we've got another sequence, 7, 1, negative 5, and negative 11. And we've been asked to find the nth term for that sequence. Now this time it's getting smaller. So that means that rather than being such a, something such as 6n or 10n and so on, it's going to be minus 4n or minus 7n because it's getting smaller each time. So to get from 7 to 1, we take away 6. To get from 1 to negative 5, we take away 6, and so on. So we're going to write down negative 6n. So negative 6 times 1 is negative 6, negative 12, negative 18, and negative 24. So it's like the negative 6 times tables. It's the 6 times tables, but they're all negative. So we've got negative 6n, so I'm going to write negative 6n. Now our sequence wasn't negative 6, negative 12, negative 18, and negative 24. It was 7, 1, negative 5, negative 11. So to get from negative 6 to 7, we're going to add 13. We're going to add 13, add 13, and add 13. So it's going to be add 13. So it's going to be negative 6n, add 13. So that's the nth term of that sequence, negative 6n, add 13. Okay, let's look at our next question, question number 11. So question number 11, we've been given the first four terms of an arithmetic sequence, 27, 34, 41, and 48, and we've been asked to find the nth term of that sequence and then the 20th term. So let's find the nth term. 27, 34, 41, and 48. I can see they're getting bigger by 7 each time. To get from 41 to 48, we add 7, and add 7. So let's write down 7n, and that would be 7, 14, 21, and 28. You can actually see we're adding 20 each time. To get our sequence, we need to have 7n plus 20. So it's going to be 7n plus 20. And that's it. That's the nth term of that sequence. And part B says find the 20th term. So we need to do 7 times 20 plus 20. 7 times the 20th term, so 7 times 20, and then we've got our plus 20. 7 times 20 is 140, but we still need to add 20, so that's going to be 160. So the 20th term in the sequence would be 160. Okay, and then part C. Part C says show that 380 is not a term in the sequence. So if you want to show if something's in a sequence, a term in a sequence or not in a sequence, you put the nth term equal to that number and then you solve it. If you find that n is a whole number, then it's in the sequence. But if it's not a whole number, such as a decimal, then it's not going to be in the sequence. So let's write that down. The nth term was 7n plus 20. That's what we had in terms of part A, 7n plus 20. And then we're going to put that equal to 380. And now we want to show it's not a term in the sequence. So hopefully when we solve this, it's going to be a decimal number. And that means that it's not a term in the sequence. So let's take away 20 and take away 20. We're doing that to get the 7n on its own. So we've got 7n on the left hand side. We took away 20 to get rid of the plus 20. And then 380, take away 20 would be 360. Now we want to get rid of this multiply by 7, so we're going to divide by 7 and we're going to divide by 7. And again, if you need a recap on solving equations, if you go to Corbettmaths and watch the video on solving equations, that'll be useful as well. Now in terms of this question, it is a calculator question, so that's nice. So 7n divided by 7 is just n, 1n which is n, and then we're going to do 360 divided by 7, and that's equal to 51.42857 and so on. So that means that 380 would be the 51.428 and so on term in the sequence. Well, that doesn't make sense. So it's not a term in the sequence. So let's just write that down. And I've just explained that. I've explained that since n is not a whole number, the 380 is not a term in the sequence. Okay, let's look at our next question. Okay, so question number 12. Question number 12 says the first two terms of an arithmetic progression are 5k and 10k, and we've been asked to write down the next term. Okay, so it's an arithmetic progression. That means it's getting bigger by the same amount each time. So to get from 5k to 10k, we add 5k. We're adding, so adding 5k. So to get the next term in the sequence, we need to add another 5k. So 10k plus 5k will be 15k. So the next term in the sequence is 15k, and that's it. Okay, question number 13. Okay, let's have a look at our next question. Question number 13. Yasmin attended a 4-year college course, and at the end of each of the 4 years, students on the course sit an examination. And the number of marks that examination is worth over the 4 years form an arithmetic progression. So that means obviously that the number of marks that it's worth, that examination at the end of the 4 years, that it's going to be getting bigger by the same amount each time, or smaller, but as you can read here, it's bigger. And then the question says the examination at the end of the first year was worth 75 marks. It says the examination at the end of the second year was worth 110 marks. And then it says in order to pass the course, the student needs to obtain at least 60% of the total marks over the 4 years. And she scored 309 marks, and the question says, did Yasmin pass the course? Okay, so let's work out how many marks each of the examinations is worth. So we've got 75, that's how many marks are available in the first year exam. The second year exam is worth 110 marks. Now, because it's an arithmetic progression, it's going to get bigger by the same amount each time. So let's do 110 subtract 75. And if we do 110 subtract 75, that's equal to 35. So that means that every single year the examinations were 35 more marks. So 110 plus 35 is 145, plus another 35 would be 180. So that's how many marks are available for each of the examinations over the 4 years. Now the question continues and it says in order to pass the course, the student needs to obtain at least 60% of the total marks available. So let's add these together and work out what the total available marks are. So let's do 75. So 75 plus 110 plus 145 plus 180. And when we add them all together, we get 510. So there's 510 marks altogether. Now the question says that a student needs to obtain at least 60% of the total marks. So we need to work out what 60% of 510 is. So to get 60% of a number, we're going to divide by 100 to get 1% and then times by 60. So let's take 510 and divide that by 100 to find 1%. That's going to be equal to 5.1. And then we're going to do 5.1 multiplied by 60 to find 60%. And when we do 5.1 times 60, we get an answer of 306. So that means that a student needs to score 306 marks to pass. Now Yasmin has scored 309 marks. Now 309 is bigger than 306. So that means that Yasmin has scored more marks than she needs. That means she's passed the course. So did Yasmin pass the course? The answer is yes. And that's it. Okay, let's look at our next question, question number 14. So question number 14 says the first three terms of an arithmetic sequence are 2a plus b, 3a plus 6b, and 4a plus 11b. And the question says write down the next term in the sequence. So we want to find the fourth term in the sequence. So remember, it's an arithmetic sequence. That means it's getting bigger by the same amount each time. So we've got 2a, and then we've got 3a. We've then got 4a. So the next one will be 5a, because we're adding an a every single time. In terms of the b's, we've got b. We've then got 6b, so we've added 5b. Then we've added another 5b to get 11b. So we're going to add another 5b. So 11b plus 5b would be equal to 16b. So 16b. So the fourth term in the sequence, or the next term in the sequence, would be 5a plus 16b. And that's it. Okay, let's look at our next question, question number 15. So question number 15 says the first three terms of an arithmetic sequence are 2k minus 1, 5k plus 2, and 8k plus 5. And the question says find in terms of k the 10th term of the sequence. So we want to find the 10th term of the sequence. We've got the first term, the second term, and the third term. So we need to carry on until we find the 10th term. Now I'm going to do this question two different approaches. One approach is I'm just going to carry it on and find out what the 10th term is. Another approach I'm going to do is I'm going to find the nth term for the k's and the nth term for the numbers and then work out what the 10th term would be. Okay, so the first term is 2k minus 1, and then 5k plus 2, and then 8k plus 5. So in terms of the k's, we've got 2k, 5k, 8k. We're adding 3 k's every single time. And then in terms of the numbers on the end, we've got minus 1 and then 2, so that's adding 3, and then adding another 3. So every single time we're adding 3k and 3. So that means it'll be, if we add 3k, 11k, plus 3, so it'll be plus 8. The next one, add 3k, 14k, and then plus 3, plus 11. So that's 1, 2, 3, 4, 5 terms. We need to do 5 more. So if we add 3k, that's going to be 17k. Then add 3, that's going to be plus 14. Add 3k, that's 20k. Add 3, that's plus 17. Add 3k, that's 23k. Plus 3, that's plus 20. Plus 3k, that's 26k. Plus 3, that's going to be plus 23. And finally, plus 3k would be 29k. Plus 3 would be plus 26. So the 10th term in the sequence would be 29k plus 26. And that's our answer. So that was one approach. Another approach is to find the nth term for the numbers of k's and find the nth term for the numbers on the end. So in terms of the numbers of k's, we've got 2k's and then 5k's and then 8k's. So let's find the nth term. It's getting bigger by 3 each time, so it's going to be 3, 6, and 9, and that would be 3n. But in terms of our sequence, it's 1 smaller. We're going to take away 1, take away 1, take away 1. So the nth term for the number of k's would be 3n minus 1. And that's the number of k's. Now we want to find the 10th term. So 3 times 10 would be 30. Take away 1 would be 29. So 3 times 10 is equal to 30. Take away 1 is 29. So that means there's 29 k's. So it's 29 k's, 29 k's. That's the number of k's, 29. And then in terms of the number on the end, we had minus 1, 2, 5. So here you can see it's getting bigger by 3, getting bigger by 3. So it's going to be 3, 6, 9, and 3n again. But this time we're taking away 4, take away 4, take away 4. So it's going to be 3n minus 4. Now we want to find the 10th term. So 3 times 10 is 30. Take away 4 would be 26. So it's going to be plus 26. So the 10th term in that sequence is 29k plus 26. Or you could have just carried on the sequence and done that, and you would have got 29k plus 26 as well. Okay, let's look at question number 16. Okay, so question number 16 says the first 3 terms of an arithmetic sequence are 2k, 11k, and 20k, and the sum of the first 6 terms is 1029. Work out the value of k. Okay, so we want to find the value of k. So we want to find the first 6 terms. So we've got the first, the second, the third. Let's find the fourth, the fifth, and the sixth. So in terms of our arithmetic sequence, it's getting bigger by the same amount each time. So we're adding on, add 9k, add 9k. So if we add another 9k, it'll be 29k. Add another 9k would be 38k, and adding another 9k would be 47k. So that's our terms in our sequence. And it's a calculator question, so you could add 9 using your calculator if you want to, but it's fairly straightforward. Now we need to add this up. We need to add up these expressions, these algebraic expressions for each of the terms, and find out what that is, because we know the sum of the first 6 terms. So let's do 2 plus 11 plus 20 plus 29 plus 38 plus 47 on our calculator and see what we get. And that's equal to 147. So that means if we add up these algebraic terms, we're going to get 147k. And that's equal to 1029. So that equals 1029. Now we want to find out what k is, so let's divide both sides of this equation by 147. So divide by 147 and divide by 147. So if we divide the left hand side by 147, we're just going to get k. And then if we do 1029 divided by 147, we get that's equal to 7. So k is equal to 7. So the answer is 7, and that's it. Okay, let's look at our last question, question number 17. Okay, so question number 17. Question number 17 says the first 3 terms of an arithmetic sequence are x plus 16, 5x minus 1, and 2x plus 38. And we've been asked to work out the value of x. Now if we have a look at these terms, we've got x plus 16, 5x minus 1 and 2x plus 38. In terms of the x's, it goes x and 5x and 2x. So in terms of these, we're not going to be able to just look at it and say, well, we're adding on so much each time. But we know with an arithmetic sequence that we're adding on the same amount each time. So we know that the second term, take away the first term, the difference between them, will be equal to the third term, take away the second term, the difference between them. That difference is the same as that difference, because that's what an arithmetic sequence is. It's got a common difference, the same difference. So let's do the second term, 5x minus 1, and let's take away the first term, which is x plus 16. So we're going to do 5x minus 1, take away x plus 16. And we're going to see what that is. So 5x, take away x would be 4x, and then minus 1, minus 16, well, minus 1, take away 16 would be minus 17. So that means the difference between these two terms is 4x minus 17. And that makes sense, because if you've got x and you add 4x, you get 5x. And if you've got 16 and you take away 17, you get minus 1. So that's the difference between those two terms. Now let's find the difference between these two terms. So we're going to do the third term, which is 2x plus 38. And we have to do the third term, take away the second term. So then take away 5x minus 1. Close brackets. Now 2x take away 5x would be minus 3x, and then we've got 38 minus 1. So it's going to be 38 plus 1, which is 39, so plus 39. So the difference between these terms is minus 3x plus 39, because if you've got 5x and you add minus 3x, you get to 2x, and if you've got minus 1 and you add 39, you get to 38. Now, because this is an arithmetic sequence, the difference between these two terms will be equal to the difference between these two terms. And I'm just going to write that down, and I'm just going to change colour of ink here. So this difference is the same as this difference. So let's write that down. That 4x minus 17 will equal minus 3x plus 39. Now we just need to solve this. So let's add 3x's to both sides. I want to get rid of the lowest number of x's here, which is minus 3x. So let's add 3x and add 3x. 4x's plus 3x's is 7x's, and then we've got minus 17, and then on the right hand side of the equation we've got minus 3x plus 3x, that's 0, and then we've still got our 39. So we've just added 3x's to both sides of that equation there, and now we want to solve this equation. So let's add 17 to the left hand side and add 17 to the right hand side, because we want to get rid of this minus 17. 7x minus 17, add 17 will just be 7x, and then 39 plus 17, well 39 plus 17 will be equal to 56. And then finally, we want to find out what x is, so let's divide by 7 and divide by 7. And you're going to get that x is equal to 56 divided by 7 is equal to 8. So x is equal to 8. And the question says find the value of x, that's going to be 8. And that's it. And that's it. So these have been the video solutions to the Corbettmaths Practice Questions on Arithmetic Progressions. I really hope you found this video useful. If you have found it useful, please like it and please subscribe to the YouTube channel. If you need any extra help on Arithmetic Progressions, if you go to Corbettmaths and go to the Videos and Worksheets section and scroll down to video number 374, there's a video tutorial there on Arithmetic Progressions. Alternatively, at the end of this video, if you have a look at the end, there may be an icon for a video for you to click on, which is the Corbettmaths video on Arithmetic Progressions. And also at the end of the video, there'll be an icon for you to subscribe to the YouTube channel as well. So again, I really hope you found this video useful, and if you have found it useful, please like and please subscribe. Thank you. Cheers. Bye.